Hi, I'm Navid, speaking to you from Australia. I'm a physical oceanographer working at the Australian National University. My research involves a combination of theory, pen and paper, solving equations on the computer, analyzing model output, and oftentimes writing software. Today I'm going to talk a little bit of how I use GitHub in my day-to-day workflow. So what is GitHub? And what is Git? Is it just a shorthand? Git is a version control system, something that allows you to save snapshots of your files. GitHub is an online service that holds Git repositories. Plus it has many other features that allows effective collaboration. I know this is pretty short introduction, but we have to move on. So what are some things I do in GitHub? Well, while working on a research project, for example, I will use GitHub to store my scripts and notebooks as they are evolving. And this way I have a snapshot of all my work days, and I can return back to a previous state if I realize that I went down a rabbit hole, for example. And then when the research project is over, then I have a way to share my scripts and notebooks with everybody and then allow everybody to reproduce my results. So before GitHub, I somehow always ended up having multiple versions of my scripts for a research project I was working, and each version had conflicting changes with each other. It was a big mess. By moving my workflow on GitHub, it helped me become more organized. I also did a conscious effort to become more organized, but that's a different story. For each research project, I have a GitHub repository where I store my notebooks and scripts that do all the analysis and produce figures. And this way I can go back and reproduce my figures, and I can also go back and see how my analysis were done in some other point previously in time. When all dust settles, then usually we have to write a paper. I do that in GitHub also. This way I have a snapshot of my LaTeX source files at every instant, and also collaborators can chip in and suggest changes via pull requests, and that makes it very easy. And also it avoids people working together on the same file and undoing each other's changes, which has happened to me a lot. So the last thing I want to touch on is how I use GitHub to develop software, and more importantly, how I use GitHub to collaborate with other people and develop software together. I can't imagine how I would be doing that without GitHub. So to talk more about how GitHub enables collaboration, I'll put on my GitHub hat and invite a friend of mine and collaborator to join us. Hi, Greg. Can you introduce yourself?
Hi, Navid. Yeah, I'm Greg Wagner, and I'm a researcher at MIT. Like, one of the most important aspects of GitHub is communicating effectively. It's not just about the details of version management and blah blah blah. It's about working with people and working with people, on the same, collaborating with people on it's about collaborating, right?
Yeah. Well, why don't we share your screen and show some issues that kind of like demonstrate that, perhaps.
Yeah. So I'm going to Oceanography because that's what
go to Oceanography. That's a good example. What's oceanography?
Julia software for fast, friendly, flexible, data-driven, ocean-flavored fluid dynamics, and it runs on GPUs too.
Right.
It's ocean modeling software from anything from classroom problems to GCM.
All the development is done via GitHub. What
Yeah.
do we? I mean, how does GitHub enable that?
Yeah. So, well, I guess like the basic thing is that GitHub hosts the code. The main thing is that there is a source code file and there's examples. There's documentation, which is also hosted by GitHub. And there's tests for the code. All that code is hosted here. But obviously it's much more than that. So it's also this environment for making changes to the code. So usually we do that through pull requests. It's an environment for isolating problems or create issues, or sort of a to-do list. Like, here are the problems to fix, here are the features to add. The discussion section is really cool because
let's go there.
principle.
Let's go there.
Yeah.
Let's see how a discussion started and how it evolved.
It's like a Stack Overflow style question and answer environment. Yeah, somebody asked they want a periodic Coriolis force for a planet with 2 equators. That's crazy.
That sounds
It's probably hard. It's hard to ask a crazier question than that. So, I mean, we all, you live in Australia, I live in Utah. So how are we going to work together? We need a way.
Yeah.
This is the way.
This is the way to do it, even asynchronously. I work on one piece of code on my daytime work day, and then I pull up a pull request, and you wake up and you see it, you comment on it.
The other aspect of a PR is we're trying to make changes to the code, and part of that is we have this test suite that we always want the test suite to be passing, because otherwise the code might not work. So when we open the PR in Oceanography, it runs all the tests, and so that allows then we can see if tests are failing, we see why, we see the error message, we can collaborate on fixing the errors. That's a huge aspect of being productive on the PR.
Or sometimes we discover that the test was not good enough and the test has to be changed.
Yeah, either the test is wrong, right? Sometimes tests are not perfect.
Perhaps you can stop sharing and we can have some final concluding remarks on GitHub and how it has changed. Greg, let me just ask you something as part of this little interview we're having here. How has GitHub transformed your work life the past 2-3 years?
It's completely changed everything. All the work I do, even science discussions, I try to have a big majority of the science discussions I have on GitHub, because it's 100% open and everyone can see. And I just think that's crucial. Okay, here's an issue about implementing a surface wave model. So the other examples were code, but this is actually a discussion about science. I'm having it in an issue just because I want everyone to see and I want feedback from everybody. And there is a little bit of code at the end. So I'm talking about what surface wave model to implement. Ching-Li gives me some feedback and I said, okay. He gave me some references to other software that would help. That's also on GitHub. So I could just click the links and go to that immediately. I tried something, so I implemented a certain function. It's like a vertical profile of the Stokes drift, and I had a bug in it. So I posted the image, and then I posted the code that I used to make the image, and Ching responded, and he said, "Hey, this little snippet, there's an error, sign error. The plus was supposed to be minus," and that was it. So then I changed it. Now it's correct. And I just think, we're just all working together on this big human project, and why not do it on GitHub?
Exactly.
So.
All right.
It's changed my life for the better. Yeah, I think
Greg,
it could change all our lives.
it has changed my life personally also. It has changed the way I interact with you and with all the GitHub community. So perhaps with this note, we close this and we leave it open for discussion. Thank you for joining us today.
It's been a pleasure.
All right.
As always. See you on GitHub.
See you on GitHub.